This next problem says 0.78 moles of strontium chloride are dissolved in 0.985 liters of water. What is the percent by mass of the solute? So we need to make a couple of conversions here in order to solve this problem. We need grams of strontium chloride and we need to have grams of water. We know water has a density of 1 gram per milliliter, but because our volume of water is in liters, we're going to have to convert to milliliters in order to have our correct number of grams. So let's go ahead and do that first. That conversion's pretty easy. We have 0.985 liters. And so we're just going to convert our liters to milliliters. There are 1,000 milliliters in 1 liter. And then we can just go ahead and show our conversion from milliliters to grams of water, because water has a density of 1 gram per 1 milliliter, which is why we're able, when we have milliliters as our volume of water, we're able to just immediately convert into grams because of the density of water. So 0.985 times 1,000 will give us 985 milliliters, which means that we have 985 grams of water as well. So that takes care of our amount of solvent, because H2O is going to be our solvent. Now we just need to figure out the mass of our solute, which is strontium chloride. So we need to figure out that mass of our solute strontium chloride. Before we go any further, we are going to have to make a mole to gram conversion, which means we need the correct formula for strontium chloride. So let's go ahead and do our crisscross. Strontium is Sr, and it has a positive 2 charge. And then chloride, that "ide" ending, tells us that it's the element chlorine on the periodic table, which has a -1 charge. So our formula is SrCl2. Now that we have our correct formula, let's do our mole conversion. We have 0.78 moles of SrCl2. We'll put it over 1, and we're just doing a simple mole to gram conversion. Moles goes on bottom, grams goes on top. We know our mole is the bigger unit, so 1 mole equals some number of grams of strontium chloride. We'll add up our molar mass up here. Strontium has a mass of 87.62. And we just have 1 strontium plus the mass of our chlorine, which is 35.43. And then we have 2 chlorines. We have to multiply that mass by 2. So 35.43 times 2. Or sorry, I actually wrote the wrong mass here, 35.45. I copied it down wrong. 35.45 times 2 plus 87.62. That gives me an overall mass of 158.52 grams. We'll substitute that in, 158.52. And then we will multiply that by 0.78 moles to get our total mass of strontium chloride of 123.64, but I'm going to 645, so I'm going to round to 65 grams of SrCl2. This is our solute, the thing that we are dissolving. Now, we know that mass percent, or the mass percent of the solute, is going to be the mass of the solute divided by the total mass. So the mass of our solute is 123.65 grams divided by that same mass again, 123.65 grams, plus the mass of our solvent, 985 grams. To convert to a percent, we will of course multiply by 100, which will get us into a percentage, 123.65 plus 985. We've got to do a little calculator work here. And then we will divide, and that gives me 11.1528%. Let's take a look at our significant figures here. 11.1528%, but we need to round. to either 2 significant figures or 3 significant figures, we will of course round to the least number of significant figures. So our final answer will just be rounded to 2 significant digits, looking at that next digit over to determine whether we're rounding up or down. It'll just round to 11%, and then this is 11% of the solute, so 11% strontium chloride, SrCl2. We will just box that final answer in real quick, and that completes number 9. On this final problem, we have 98.6 grams of copper 2 acetate dissolved in 8.9 liters of water, and it asks us what is the percent by mass of the solute. So in this case, our solute is the thing being dissolved is the copper 2 acetate, and so we already have a mass of the copper 2 acetate, but we still need to figure out the mass of our solvent, which is the water. So 8.9 liters, we need to take that amount of water, 8.9 liters of H2O, and we need to convert that liters into milliliters because we know a milliliter of water is the same as a gram of water because water has a density of 1 gram per milliliter. So we'll take this liters and we'll convert it to milliliters by multiplying by 1,000, and that gives us 8,900 milliliters of water. And we know this to be the same thing as saying 8,900 grams of water. So now we have grams of copper 2 acetate, grams of water, so we can go ahead and figure out our percent by mass of our copper 2 acetate, our solute. So our mass of our solute goes on top, 98.6 grams. And then we'll divide by our mass of both our solute, so 98.6 grams, plus our mass of our water, which we just calculated to be 8,900 grams. We'll of course multiply by 100 to get our answer into a percentage form. So let's go ahead and calculate this. 98.6 plus 8,900. That gives us 8,998.6, and then we'll just do 98.6 divided by that value. Converted to a percent, this is 1.0957%. So this solution is actually very little copper 2 acetate when you're looking at it as percent by mass. It's just over 1% copper 2 acetate. We should round our answer to correct sig figs. Both of our values given in our problem have 3 significant figures. We'll round this answer to 3 significant digits as well. That 9 is actually going to round up to a 10, which is going to make our next digit over round up as well. So 1.10, we do not need that 0 to hold the 3 significant figures. 1.10% copper 2 acetate, which I am going to actually crisscross and figure out our formula. Copper 2 has a positive 2 charge, and acetate is C2H3O2. With a negative 1 charge. So when we crisscross here, our final formula is Cu, and then C2H3O2, and 2 of those. That 2 would come down right there. So here is our final answer, rounded to correct significant figures. We have 1.10% by mass of copper 2 acetate.